Hello everyone. So my dear students, today we are going to study the introduction to impact of jets. So this particular topic is from the subject fluid machines. So myself, Engineer Naveen Kumar, Assistant Professor, Khalsa College of Engineering and Technology, welcome you in the class of fluid machines. So now we will discuss the impact of jet. So so if we see the background of this particular subject, so we have to generally we deal with the dynamics of machines. What it means? So dynamic of machines, that is the dynamics deals with the power. Okay. So dynamic machines means power machines which receives energy from the flowing fluid in the form of momentum and convert the change of momentum into the useful work. Our turbo machines like turbines, pumps, compressors, these are the turbo machines and the devices that we already know in the various subjects that we have studied till date. Okay, so these are devices in which energy is transformed by the dynamic action of the flowing fluids, either to or from a continuous flowing fluid. So turbo means which spins or whirls. Similarly, in the impulse turbine, a high velocity jet from the nozzle strikes a series of suitably shaped buckets or vanes, sometimes we call, depending upon shape, fixed on the periphery of a wheel. The wheel gets resulting momentum and it gets rotated, and thus we get the mechanical energy from the turbine. Okay. So if you go through this particular detail of the background, so you see the turbines and other energy producing devices or sometimes consuming devices like pump and compressors. So how the energy transfer takes place from the fluid to the machinery, and this is possible with the help of the energy transfer, that the initial thing that occurs, or the first part that involved into this particular interaction of the energy transfer, that is the blade and the jet of water. So water, generally when we talk about the fluid machines, generally we deal with the fluid, that is water. So here we will not discuss about the gaseous fluids, so we are just deal with the water. So whenever we talk about the fluids, you should assume that we are talking about the water as a fluid. Okay. So how the water transfers its energy to the turbines or the heavy machineries? It is just with the help of vanes or buckets, and sometimes we call it the plates. So when the jet strikes to the plate, there is impact, and this impact is occurs, and this impact occurs the force on the blade, and due to that the whole of the rotor, it starts rotating. Okay, so we will move to the next slide. So if we see, there are various type of machineries depending upon its configuration, like open and closed machines. Open turbo machines are those which deals with the indefinite quantity of fluid, like windmills, propellers, etc. These machines come under the category of aerodynamics. So secondly, enclosed turbo machines are those which deals with the finite quantity of fluid passes through a casing in unit time. Based on observation and the production of power, those which absorb power to increase the fluid pressure or head, that is for example pump, duct fans and compressors. Those which produce power by expanding fluid to a lower pressure or head, that is all the turbines. Based on type of fluid handled, so further classifications are: which handle water, that is pump and hydraulic turbines; which handle steam, we call it as the steam boilers; which handles air or gas, that is called fans, compressors and gas turbines. So these are the various type of turbo machines available, and these are the general classifications where the machines deal with the fluid, that is gases, airs and the liquid, also liquid, that is water. Okay, so when we talk about the principle on which the impact of jet works, the principle behind the work is that it comes from the Newton's second law. Okay, what it says, so Newton's second law, it says the change of momentum is directly proportional to the force. And with the help of this particular principle of Newton's, so we are able to calculate the force that the jet applies on the blades or vanes. These forces are called dynamic forces exerted by the jet, and this force is due to the change in momentum of the jet as a consequence of the impact. So how you can find the force? So force is just equal to mass striking the plate per second, and this we call it as a mass flow rate in kg per second into the change in velocity. Okay, so change in velocity means initial velocity minus final velocity. So impact of jet term refers to the study of the effect when a jet strikes on the plate or vane under various conditions. These various conditions we will see in the next slides. These are some typical vanes and plates on which the impact of jet takes place. Okay, so first configuration you can see, this is the open type of impeller of a centrifugal pump. This is semi-closed impeller of a centrifugal pump, and this is the fully closed impeller of a centrifugal pump. Here we are just taken an example to depict you the various shapes of the vanes of the turbo machines. So before moving forward, so for calculating the forces, the work done on the plates or the vanes, so we simplify the complex real situations to make our calculations easier. So we have certain assumptions for the impact of jets. Okay, these assumptions are, the first one is incompressibility. The fluid should be incompressible when we talk about the impact of jet. So we all know that the water is a incompressible fluid. Incompressible means the density should not change. So for water, it is a perfectly suitable incompressible fluid. So whenever we talk about the impact of jet, we are talking about the fluid which is incompressible, means liquids. Okay, so we will not talk about the gases here because gases are compressible fluids. Next assumption is the flow should be steady. It means it should not change with the time. Again, it simplifies our engineering calculations for designing the things. Second is there should be no viscosity. The fluid which strikes the plates, it should have no viscosity, means there should be no internal friction. वहाँ पे कोई friction नहीं होनी चाहिए. Okay, so if it is there, we neglect it. Okay, so next is the turbulence. There should be no turbulence. So turbulence flow can occur when the fluid velocity are very high and it involves chaotic fluctuations. So in our cases of impact of jet, there should be no turbulence. So we are assuming that the fluid is laminar flow. Okay. Second is the constant cross-sectional area. The jet which strikes the plate, it should have constant cross-sectional area. It should not vary from point to point. So it again simplifies our calculations. Then the next one is there should be no external force. Okay, the whatever forces involved in this particular system, that is the jet force that occurs due to the jet of water. Apart from this, there should be no other forces we are going to consider. Okay. Next is the surface of the plate should be perfectly rigid. Okay, what it means, there should be no deformation when the jet strikes to the plate. Okay, there should be no deformation. It should be perfectly rigid. The last one is there should be no heat transfer. Heat transfer rate due to the impact of jet are neglected. So we know that there is some friction and there is a heat generation. As you know, in our previous assumption, हमने कोई viscosity यहाँ पे assume नहीं किया है, and that's why there is no internal friction, and so there is no chance of heat generation also. Okay, I think so. You must remember these assumptions while we do some calculations later. So impact of jet on a stationary flat plate. Our first and simple case that we are going to study is the impact of jet on the flat surface. So we are considering, so this is the flat surface and this is the nozzle through which water jet comes and it strikes the plate. This plate we are assuming that it is a flat plate. Okay, after striking the plate, the water get deflected on the both direction. In all the direction it means. Here we are just able to see the two direction, upward and downwards. Okay, so let us consider the cross-sectional area of the jet as small a, v the velocity of the jet, m is the mass of water striking the plate per second, and further we know that the mass flow rate is as rho av, where rho is the density of water, kg per meter cube, and the force on the jet by the jet on the plate that we can find out as change of momentum per second. That is the mass of water striking the plate per second multiplied by the change in velocity. So m is the mass flow rate, v is the initial velocity, and we know that the final velocity in this case in the direction of force is 0, because this is in this direction there is a no velocity. Okay, velocity is not, suppose this direction is x, so in x direction there is no jet velocity, only in the y direction the velocity is. So final velocity is 0, so initial velocity is v, so it is m into v, and we know that m is nothing but rho av, that is density multiplied by area of accretion into the jet velocity, initial velocity. So it is rho av square. So we can find out the force as rho av square in case of a flat plate. So in previous case, when the plate is fixed, if you move previous, you can see that here we have just find out the forces. There is, when the plate is fixed, there is no work done. Okay, so our next case is the direct impact of jet on a moving plate. So when the plate is also moving, there will be a relative motion between the jet and the plate. So if the v is the velocity of the jet and u is the velocity of plate, then the relative velocity is v minus u, and we always know that the v is will always greater than the u, so relative velocity is v minus u. So force exerted by the jet on the plate, how we can find out? We can find out as, again, the same formula, that is change in momentum, that is mass flow rate into change in velocity. So it is rho a, instead of v square we are taking over here v minus u square. So, and as it is also moving, so we are here finding the work done by the jet on the plate per second as f multiplied by the velocity of the plate. So we are getting the work done as Newton per second or Joule per second. So that is rho v square, that is the force, into u. So here we are getting work done as work done per second. We are, because we are not multiplying the force with the distance, but we are multiplying the force with the velocity. So it is Newton meter per second or Joule per second. We call it also power also. So our next case is the force exerted by the jet on a series of vanes. So in previous cases we have just considered a single vane. Okay, but in actual practice you might have seen on the runner or on the rotor there are numerous vanes. If we talk about the Pelton turbine, you will find out that there are the minimum 16 to 20 blades will always there on the runner. Similarly, in case of Francis turbine, a similar number you will find, and when you see the Kaplan turbine, you will find there is the 4 to 6 vanes or plates are there. In the household fans, you might have seen there is a 3 at least blades are there. Similarly, in the exhaust fan, you might have seen 4. Okay, so always there are more than 1 vanes or buckets are there. Okay, so we have to study the effect of the water jet on the series of vanes. So there is a only change when we talk about the series of vanes, that so mass flow rate, that is rho a v minus u. Okay, so in place of rho a v minus u, we will just consider rho a v, because here in case of series of vanes, we assume that there is always a vane in front of the jet. Okay, so once this jet strikes this particular plate, it will move away and the next plate will come in front of the jet in no time. So this is again some a sort of assumptions, okay, and that we take. So only change in the calculations of forces and work done will be m dot, or the m, that is rho mass flow rate, that we are going to consider as just rho a v, okay, not rho a v minus u. So in case of series of vanes, we are not considering the relative velocity but the absolute velocity. Okay, so work done, the formula you can see here, Fx is rho a v into v minus u. So this is the mass flow rate, mass of water stacking the series of plates per second, into initial velocity minus final velocity. So initial velocity is the relative velocity, that is v minus u, and the final velocity is 0. So the formula is rho a v into v minus u. So students, you must remember this particular point. Okay. So when to consider mass flow rate, or what to consider in the mass flow rate in case of a single plate, or when, and what to consider in case of series of plates. आपने बस इतना ध्यान रखना है कि जब हमने सिंगल प्लेट के साथ कैलकुलेशंस करनी है, तो हमने मास फ्लो रेट जो है मूविंग के केस में रिलेटिव वेलोसिटी हमने लेनी है, दैट इज v माइनस यू इन केस ऑफ द मास फ्लो रेट. बट जब हम सीरीज ऑफ वेन्स की बात करेंगे, तब हमने वहाँ पे जो मास फ्लो रेट है हमने वो रो ए वी ही हमने लेना है. ओके, सो दिस इज द डिफरेंस. Our next part is to find out the efficiency. Okay, so once you know the power, you can find out the efficiency. How we can find out the efficiency of the jet? So all of you are familiar with the simple formula that we use, that is efficiency is equal to output upon input. Okay, so what is the output? The work done that we have found just before, that is force into distance moved per second. So distance moved per second is nothing but the velocity. So work done per second by the jet is Fx into u, and Fx is what in case of series of vanes? Rho a v into v minus u. So this is the force multiplied by the distance moved per second, that is the u. So from this we are getting the work done per second as the output. This is our output. And next is the kinetic energy of the jet. So kinetic energy, how we can find out? We all know that half formula for that is half mv square. So here kinetic energy of the jet per second. It's not just kinetic energy. Okay. So it is half mv square. So half m, what is m? M is the mass flow rate. Okay, and that is rho a v multiplied by v square. So what we are getting ultimately? It is half rho a v q. So efficiency is equal to work done per second by the jet to the kinetic energy of the jet. Okay, so efficiency is rho a v into v minus u into u upon the kinetic energy of the jet, that is half rho a v q. So if you simplify, you will get it as 2u into v minus u upon v square. And when we apply the condition for the maximum efficiency, okay, so you will find out that the maximum efficiency in case of flat plate, the jet strikes to a flat plate, series of flat plates, that is 50%. Okay, and here the condition that we get as u equals to v upon 2. It means the blade velocity should be half of the jet velocity. Okay, so this is the condition. So sometime in the examination it comes to prove that in case of series of flat vanes, the maximum efficiency is 50%. Okay, in that particular case, you have to go through this particular calculation. So you might have seen that these calculations are not difficult. Okay, this is very simple. Just you have to find out the force, and for finding the force, you have to just use the Newton's second law, that is rate of change of momentum. Okay, that is directly proportional to force. Okay, that is the mass flow rate into change in velocity, initial minus final velocity. And when you know the force, you have to just multiply it with the distance moved per second, that is the velocity of the blade. You will get the work done per second. And for the kinetic energy, you know the formula, half mv square, and here kinetic energy per second, so it is half mass flow rate into v square, and mass flow rate is rho av, so it is rho av q. Okay, in this manner you can prove this particular derivation if it is asked to you in the examinations. So next we will see the most important part, that is the general case. Okay, that is the velocity triangles. So this is the velocity triangle on a typical curved vane. Okay, so one is inlet velocity triangle and other is the outlet velocity triangle. Okay, so in the velocity triangles there are few important terms. Okay, so that you must know. Okay, the first is the velocity of the jet. So velocity of jet is v. Okay, this is represented by the triangle side AC. Okay, again next is the v1, the velocity of jet when it is leaving the van. Okay, so Eg is this one. Okay, so this is the initial jet velocity v, and this is the final jet velocity at the outlet, that is v1. It is represented by Eg. Similarly, u1 and u2 are the velocity of vanes, that is represented here by AB and EG. So this is AB. So this particular line represents the vane velocity or blade velocity at the inlet. Similarly, this FG, this particular arrow, so this FG represents the blade velocity at the outlet. Okay, so what are the two velocities that we have understood right now? First is the jet velocity at inlet and outlet, and similarly the blade velocities at the inlet and outlet. Next is the angles. So alpha is the angle with the direction of motion of the vane at the jet where it enters. So this is called absolute jet angle. Okay, this is represented by alpha. Okay, and similarly at the outlet, this is beta. Okay, so alpha is the angle of jet at inlet, and beta is the jet angle at outlet. So relative velocity, as the blade and the jet both are moving, so the relative velocity term will come into the picture. So relative velocity is here represented by VR at the inlet and VR1 at the outlet, that is by BC. So this is absolute velocity V, this is blade velocity V, and this is the relative velocity VR. Similarly at the outlet, this is the absolute velocity, this is the blade velocity, and this is the relative velocity EF. Okay, so theta angle which VR makes with the direction of motion of the vane, that is called vane angle at inlet. So this theta is vane angle at inlet. Okay, and here this is beta and vane angle at the outlet. So different books uses different notations. Okay, so the relative velocity that makes an angle with at inlet and outlet, that are called blade angles. Okay, and the absolute velocities that makes an angles at inlet and outlet, that is called jet velocities at inlet and outlet. So absolute velocities are having two components, one is horizontal and other is vertical. So horizontal component is called world velocity and the vertical component is called flow velocity. So similarly at the inlet we call it as VW and at outlet we call it as a VW1. In different books, you will find different notations. If you are using DS Kumar book, you will find it VU1 at inlet and VU2 at outlet. Okay, so you have to just remember the things. Okay, the vertical component is called velocity of flow, and the horizontal component is called velocity of world. That is world velocity. So to understand that particular velocity, okay, any velocity triangles are having three main velocities. Okay, and this is the basic equation for the velocity triangles. That is C. It is the vector sum. The absolute velocity C is the vector sum of blade velocity U and the relative velocity W. Okay, this symbol C for the velocity are used in European system, and V, that is for the velocity, it is used in the American systems. So if you are going through the American book, you will find notations for the velocity of jet with V, and if you are dealing with the European books, you will find the velocity is represented by term C. So this is the absolute velocity. Okay, this is the absolute velocity V, then this is the blade velocity, and this is the relative velocity. So absolute velocity is the sum of relative velocity and the blade velocity. You must remember this particular expression. Okay, so with the help of this expression, you will always in a position to correctly mark the direction of the velocities, whether it is positive or negative, upward or downward. Okay, so it is important to remember this particular expression. Okay, that is the absolute velocity is always a vector sum of blade velocity and the relative velocity. So again, so the various components of the velocity triangle is explained over here. Okay, so it is, so whether the direction of this wall velocity will be in positive direction or negative direction, okay, it all depends upon the this particular equation. Okay, that is the absolute velocity is the sum of relative velocity and the blade velocity. Okay, so this was all about the impact of jet topic or the subject that we have discussed. So next we will have some certain questions and answers you might have in your mind. So let us deal with the questions. So the first important question that comes from this particular impact of jet chapter, that is, point out the significance of word free in impact of free jets. Okay, so students, you must be able to answer this particular question. The second question which generally arises from this particular chapter is the define the term impact of jet. Okay, so this question is slightly easier to answer, and hope you all will be in position to answer this particular question. So later we will discuss in the class. So what are the assumptions of the impact of jet? So we have already discussed this particular in detail. So you must be in position to write down if it is asked to you. So what are the various assumptions that we take in case of impact of jet, and why it is important and why it is necessary? You must be able to answer it. Okay, in certain other studies you might have having the assumptions, and you know the why it is kept while doing some experiments or some derivations. Okay, because it is not possible to deal with the complex situations, and all practical situations are very complex, so we must use some simplifications to come at the conclusion without losing the correctness. Okay, so another question is explain impulse momentum equations. So this is the most important question from my as far as my thinking is concerned, because this is on this equation the principle of the impact of jet is based. So without impulse momentum it is not possible to calculate or find out the force, and if you are not able to find out the force you cannot find the work done, and if you are not able to find out the work done you cannot find out the efficiency, and if you don't know efficiency how you can design a efficient system or efficient design or efficient machinery. So it is very important to know the principle. So for the impact of jet, the most important principle is impulse momentum principle. Okay, so I hope you are all in a position to answer this particular question. So sometime you can draw the figures, you can write down the expressions. So it is not always advisable to just write the certain sentences or lines to answer a particular question. So in the engineering it is always advisable to you to draw the figures, drawings and expressions. Okay, the fifth question is determine the force exerted by a jet on a stationary flat plate held normal to the jet. Okay, so this is the first case that we have seen where the jet strikes a flat plate and that is fixed normal to it. Okay, so how to find out the force? You have to use the impulse momentum principle and you can find out the forces. Okay, so what are the other things that you have to assume here? Over here the area of cross section of the jet is important and the density of the fluid, okay, and the velocity of the jet. So these are the important points that you must remember for the derivation. Okay, next question, find out the expression for the force exerted by a jet on the stationary inclined flat plate. So if you are in a position to find out the forces on the flat plate, I think you are smart enough to find out it in the inclined case of inclined plate. Okay, so you can find out the forces on various inclined plates. Okay, flat plates. So here I think the question is get repeated 6, 7, 8, 9, 10. So you have to just do a correction. In case of flat plates you have to change it with the curved plates. Okay, so question number 7, you have to calculate it for the, so I just making the changes over here. Okay, so in the last slide, so it is not the inclined flat plate. Okay, so it's stationary but it should be the curved plate. Okay, so it is curved plate, and how, what is the type? Symmetrical. Okay, symmetrical. Okay, symmetrical curve plate. So in case of symmetrical curve plate, so angles at inlet and outlet remains similar, and otherwise you have to take different. So our next question will be stationary curve plate, and what type? Unsymmetrical. Okay, so first one is symmetrical and other is unsymmetrical. Unsymmetrical means the angles at inlet and outlet will be different. So you have to take different angles just. And the last one is, in case of stationary, you have to consider it as a moving inclined flat plate, and the next one is when the jet strikes a moving curved not flat but curved, moving, symmetrical curve plate. Okay, and you can similarly find it for unsymmetrical curve plate. Okay, so these are the changes that we have done over here. So if you have any questions, or if you find any difficulty in doing these questions, so you can write in the comment box. I will answer your queries. And similarly, apart from these other questions, if you have any other questions in your mind, that also you can ask. Hope you have understood the basics of the impact of jet. Okay, so impact of jet, and this particular topic have certain other uh, areas of applications, that is turbines, pumps, and you know that use of turbines are used for energy generations. So turbines are used in the power plant, turbines are used in the aviation systems, the gas turbines, in steam turbines in the ships. Okay, so various applications it has. So hope you understood, and thank you for giving time and value. Okay, so thank you very much. So we are stopping over here.